All last week we worked with solving different kinds of equations. Today we're going to be doing something similar but a little bit different, and that is solving inequalities. So an inequality basically just means two things that are not equal, so kind of the opposite of an equation. An equation is a mathematical statement that two things are equal. An inequality is a mathematical statement that two things are not equal. So instead of using an equal sign in these, we're going to be using symbols like these, which mean greater than or less than. So greater than or less than. Now you always read these from left to right. So if the bigger number is on the left, I would say 7 is greater than 5. So the bigger number's on the left, I use the one that is open toward the left. For less than is for when the smaller number is on the left. So if I would say 5 is less than 7. And again, the open part is still towards the bigger number. So it's just reading left to right. There's also versions with lines underneath them. This would mean greater than or equal to. So greater than or equal to. So that means if I had something like x is greater than or equal to 7, that means x could be any number bigger than 7, or it is allowed to equal 7. So it could be 7, 8, 9, 10, 11, 12, or anything beyond there. And then I could have less than or equal to. So less than or equal to. So if I had x is less than or equal to 5, that would just mean x has to be any number that's either less than 5 or x is allowed to be 5, but definitely nothing bigger than 5. So we're going to work with trying to solve some of these. Now, solving an inequality is almost exactly like solving an equation. There's just a couple small differences. So if I had the inequality k plus 3 is greater than 4, well, to solve this, I would do it just like I would an equation. Try to get the variable by itself. So I would subtract 3 on both sides, and I would end up with k is greater than 4 minus 3 is 1. So k is greater than 1. So I solved that just like I would an equation. The biggest thing that's different here is usually when we're solving these, we're also going to graph our solution because it's not just one number we're finding here. There's actually an infinite number of solutions. K is allowed to be anything bigger than 1. So k could be 1.2, or k could be 7, or k could be 100 million, or anything greater than 1. So to show this answer, we're going to graph it on a number line. So you're going to draw a number line. On this number line, you're just going to label some numbers. So if that's 0, 1, 2, 3, this way would be -1, -2, and so on. I'm not going to give you a specific, you have to say like 7 numbers on your number line or anything like that. As long as you show essentially the number you're concerned with, which in this case is 1, and then maybe 1 or 2 numbers on either side of it. I'm happy with that. Now when I graph this, I'm going to show that k is allowed to be anything bigger than 1. So k could be, here, k could be here, here, anywhere down here. So the way we're going to show that is from 1, I'm just going to draw an arrow that goes to the right. So my arrow here is kind of shaded in. But the thing I have to ask myself is k actually allowed to be 1? Well, no, it's not. K has to be greater than 1. So I'm going to put an open circle here on 1 to show that 1 isn't actually included, but that's where my arrow starts, is everything to the right of 1. So I use an open circle there to show that 1 itself is not part of the solution. And now we're done with this problem. We solved it and we graphed it. Let's try another one. This time 3x plus 2 is greater than or equal to 11. So I'm still going to solve this just like any other equation. I would subtract 2 on both sides to get rid of plus 2. That would leave me 3x is greater than or equal to 9. And then divide both sides by 3. to get x by itself. So x is greater than or equal to 9 divided by 3 is 3. So x can be anything bigger than 3, or it is allowed to be 3. X is greater than or equal to 3. So when I draw my number line, it's going to be, again, it doesn't have to necessarily start at 0. If I put the number I'm concerned with right in the middle, in this case 3, and a couple numbers on either side of that, that's perfectly fine. So we solved our inequality. We said x can be any number greater than 3. So x could be 3.1, x could be 4, x could be 5, or anything down here. So my arrow is going to go, again, to the right of 3. And it's going to have an arrow at the end because it does go forever. But is x allowed to actually be 3? Well, in this case it is. X is greater than or equal to 3. So this time we're going to put a closed circle at 3. 3 itself is included and everything bigger than 3. So that's kind of the difference between having just a greater than, like we did in the first problem, and a greater than or equal to, is how we graph it on the number line. So if it's just a greater than or a less than, you're going to use an open circle on the number line. If it's a greater than or equal to or a less than or equal to, you're going to use a closed circle on the number line. So if it has the equal to part, fill in your circle. If it doesn't, leave your circle open. Let's just try 2 or 3 more examples here. This one's a little bit different now because my variable is on the right-hand side of the inequality, and sometimes those get a little trickier to deal with. So let's try this one. 7 is less than or equal to 8x minus 9. So we'll still start just like we would in the other one. Get x by itself. So add 9 on both sides to get rid of that. 7 plus 9 is 16, is less than or equal to 8x. Then divide both sides by 8. So we get 2 is less than or equal to x. Well, in this case, our inequality is kind of written backwards almost, with the variable on the right. So it's a little trickier to read. So when I draw my number line, I really need to think about what numbers would make this true. So I'm going to draw my number line. I'm going to put this number right in the middle. 3, 4, let's see, that would be 1, 0. So something's going on at 2. I am going to have a filled in circle at 2 because it's a less than or equal to. But what numbers would x be allowed to be here to make this true? If x is 1, is this true? Is 2 less than or equal to 1? Well, no, it's not. But 2 is less than or equal to 3 or 4. So my arrow needs to go to the right. So even though this is a less than symbol, we need to think about what numbers of x actually work here. And in this case, it's ones to the right of 2. So our arrow would go to the right of 2. So if the variable's on the right-hand side, you might just have to think through your solution a little bit more. But it's still pretty much the same as the other problems. Just one more example to look at here. Negative 3n minus 5 is less than 1. So again, solving this just like we would an equation. So hopefully that part is pretty straightforward. Add 5 on both sides. To get rid of that, that's negative 3n is less than 6. Divide both sides by negative 3. So n is less than, this would be negative 2. So when I draw my number line, I would put negative 2 right in the middle. Be careful with how you label these with negative numbers. As you go to the right, you should be getting back closer to 0. And then 1 would be over here, and it would keep going with positive numbers. As you go to the left, you'd be getting more negative. So when I graph this, I should have, this is just a less than, so an open circle at negative 2, and we said values less than this. But we actually kind of have a problem here. And this is why it's a good idea to check your answers if you're not sure about something. if I plug in a value to the left of negative 2, like negative 3, I'm just going to check my answer to make sure this makes my inequality true. So I'm going to do negative 3 times negative 3 minus 5 is less than 1. Well, negative 3 times negative 3 is 9 minus 5. That's saying 4 is less than 1. That's actually not true. 4 is not less than 1. So even though we did everything correctly here, our solution that we got is actually not correct. And the reason for that is because of this step right here. Anytime you divide both sides by a negative number, that kind of messes up the inequality, because it was saying, this side was negative, and a negative thing is less than a positive 6. That makes sense. Anything negative is less than positive 6. But when we divide it by the negative, now this side became negative, negative 2. So this side switched from positive to negative. Whenever that happens and we're changing the sign of something by dividing by a negative number, we actually need to take this inequality symbol and flip it. So this actually should have gone from a less than symbol to a greater than symbol. So our answer actually should be n is greater than negative 2. So this actually needs to flip around, and our answer should be going this way. So the rule there is anytime you multiply or divide both sides by a negative number, so when multiplying or dividing both sides of the inequality by a negative number, you have to switch your inequality sign. So if you multiply or divide by anything negative on both sides, that inequality sign has to flip around. So let's just practice one more like that. So if we have negative 7x plus 13 is less than or equal to 6. So we would start solving by subtracting 13 on both sides. That would give us negative 7x is less than or equal to, this is negative 7. Divide both sides by negative 7 to get x by itself. And then what's going on here? We're changing this to from a negative 7, it's now a positive 1, because negative 7 divided by itself is 1. So because we divided both sides by a negative, that inequality symbol needs to flip around. It needs to change from a less than to a greater than or equal to. So then on our number line, we would put 1 right in the middle, 2, 3 over here, 0, negative 1 over there. And our solution, it's a greater than or equal to, so it's a filled in circle at 1. And values greater than 1 are to the right. So our shading would go to the right here. So because we divided both sides by a negative number, we had to flip our inequality sign around. Please don't forget to do that, or you're going to be getting some problems wrong. Anytime you multiply or divide both sides by a negative number, flip your inequality sign. So you'll have some of these problems to practice on Delta Math. Please let me know if you have any questions, and I will see you tomorrow.